Hello, everyone. Welcome to the AIDC software-focused discussion. I'm Jeff Doyle. Today, we're going to be deep diving into the QFX line of products here at Juniper. I'm joined by Michal and Himanshu from the data center team. Michal, let's start with you. We recently shipped the new QFX5240. Michal, can you tell us a little bit about that switch?
Yeah. So Jeff, the 5240 from the QFX family of products is definitely the product that is dedicated for AI DC infrastructure. Whenever you have to deploy the rail-optimized designs or inter-rail communication in order to just scale out your GPU cluster deployments, the QFX5240, which is based on Tomahawk 5 chip, is adding not only the full capacity of 51 tera in terms of forwarding, 64 times 800 gig ports, but it means 128 ports of 400 gig, right? So you can deploy in an efficient way high performance computing or AI DC clusters with that kind of switch.
That's great, but are there any software enhancements that make the Ethernet and IP fabric as efficient or maybe even more efficient than InfiniBand?
Good point, Jeff. So the software is very important here as well, right? So we mentioned about the 64 times 800 gig support, about the capacity of 51 tera. But in order to make sure you are fully utilizing your AI DC infrastructures or your HPC infrastructures, we actually add in terms of software some of the enhancements for load balancing local to the node, as well as the efficiency of the load balancing across the whole fabric. And same goes for the efficiency of the congestion management, right? We actually developed in 23.4R2 additional capabilities for the DCQCN, where at the per queue level, we can verify that the fabric is really lossless. It's fully lossless, and you can efficiently use the AI infrastructures for your applications, right?
Michal, you mentioned that the load balancing efficiency is performed at the chipset level. But is there anything from a pure IP routing perspective that we're doing with the AI ML cluster fabrics?
Yeah, that's a good point, Jeff. So as a matter of fact, so if you look at the load balancing enhancements, they have to be implemented at the chip level, right? But no matter what, you also have to make sure that the load balancing is taking into account the IP routing infrastructure, right? Is this leaf to spine connectivity exactly done the way I'm expecting it to be? That's one thing. And then we want to make sure that not only we track the bandwidth utilization local to the node, but we also incorporate the verifications of the next to next hop node in terms of quality, right? So that the efficiency of the load balancing is not only related to the local node, but we also check what's going on the next to next hop nodes. And that's where the BGP assists also the global load balancing capabilities of the QFX5240, where we load balance based on what's the quality of the path, not just quality of the links, but quality of the entire path end to end. And so BGP is using a new attribute called BGP next to next hop node. So at the IETF level, that's the new improvement we are adding in the software in 23.4R2, which we just released for AI data centers. And so we are checking not only the heartbeat information sent from the spines, where you get the information on the quality of the spine links, but also we try to verify that actually the information sent by the heartbeats is consistent with the topology whenever the topology is based on the IP underlay BGP routing. So very important stuff, making sure we have a coordination at the PFE level as well as the control plane level, both aspects equally important.
Himanshu, are there any BGP features that we recently developed in Junos for the QFX products?
Yeah, Jeff. So we know that BGP is the baseline protocol for data center fabrics. We have the BGP on the underlay, we have the BGP on the overlay, and it has a lot of features already, but still there is scope of enhancements to BGP. So we looked into BGP and what more can be done there, especially from the AML front-end networks as well as the enterprise data center. We see that when the traffic is going out of the fabrics, the link capacity could be of varying speed. And based on that, we need to send from the ingress leaf, we need to send the traffic in the right proportion to the different border devices. So BGP link bandwidth is a feature that can help with that. So we had on our Junos BGP link bandwidth cap feature for a very long time, but we added the support at the PFE level on our QFX platforms. So now we have the weighted ECMP support on our QFX Tomahawk-based platforms. So it can do the weighted ECMP and in turn support the link bandwidth feature of BGP. There is another feature called BGP minimum ECMP that we have developed, wherein we are going to conditionally advertise or withdraw the BGP routes based on the ECMP next hops that are serving the routes, right? So these are some of the important features or new features that we have added to our BGP code, and then we think that it's going to help the data center deployments a lot.
This can indeed be very helpful. But what about securing the fabric IP routing to prevent the creation of unintentional BGP peerings?
Yes. In our Junos Evolve operating system, we already have the support of TCP authentication option, which is TCP-AO, which can help with this scenario. So on our BGP peerings, we can enable this option, which will make the peering secure and in turn securing the whole fabric.
The BGP has been around forever, and it's just proving again that it continually supports innovation in not only service provider networks, but obviously in the data center.
That's correct, Jeff. That's exactly. We have a lot of innovations still coming, but we wanted to highlight today really what's shipped in 23.4 R2 release for all the AI/ML cluster deployments. Thanks for inviting us, Jeff, today.
Thanks,
Thank
Jeff.
you for being here.